Hello friends, welcome to Shiksharthi. In this video, we'll be talking about mixtures. And under the head of mixtures, we'll be talking about removal and addition in mixtures. So let's start. Now, mixtures is a topic which I feel is an extension to percentages or compound interest or ratios. Having said this, there is a reason behind it. So when I say mixtures, what are the minimum number of entities that you require to form a mixture? You require at least 2 entities to form a mixture. So can I put it like this? If the number of items are greater than or equal to 2, it is then only that we think of forming a mixture? Yes. The second question which arises here is, mixture can be formed of. Now when we are talking about mixtures, we are talking about the same kind of entities being mixed. For example, if it is liquid, we'll be mixing liquids only. If it is solids, we'll be mixing solids only. If it is a gas, we'll be talking about mixture of gases only. This is the second point to be understood here. Third point, which is equally important here, is, let us say that I'm mixing liquids. So when I'm mixing liquids, as discussed earlier, I can mix 2 or more liquids to form a mixture. Same for gases, same for solids. These are 3 important points which need to be understood before we start off with mixtures. Now, when I say 2 or more entities, we are talking about subsequent changes. So please recall the discussion on percentages that I had with you earlier in my earlier videos, wherein we talked about what is a compounded change. When 2 or more successive changes happen, that is nothing but a compounded change. That means this can be related with percentages. Mixtures can be related with ratios and proportions as well. So please refer to my ratio and proportion video also, in which we have talked about the difference between the ratios and proportions and variation. Okay, so starting off, can I say we can form 4 cases here? When we talk about removal and addition in mixtures, we can talk about 4 cases. The first case here is, these are the cases that I have made. So as a student or as a learner, it is my prime responsibility. Now when I say my, it necessarily does not refer to me only, it refers to any learner. So it is my prime responsibility to try and understand what are the different type of concepts that can be formed, and thereafter what are the different kind of questions that can be formed on the various concepts that I would have done over a period of time. So starting off with the first concept, I can only talk about removal of mixtures. Removal from mixtures is what I can talk about. At the same time, I can talk about addition in mixtures only. Third case which I can form here is removal from the mixtures followed by addition in mixtures, and the fourth case here is addition in mixtures followed by removal from the mixtures. And let us see, are they nothing but the same, or are all the 4 cases different from one another? Right? So the basic statement that I'm taking here is, for all these cases to be discussed by me, I'm taking a small kind of a question, or you can say a statement. The statement here is, I am taking there a 100 liter solution of milk and water in the ratio 3:2. This is the piece of information which is given to us. Now when we are doing the questions, when we are talking about all these 4 cases, our focus would be on volume and concentration. So when we are doing this, our focus would be on volume and concentration both. Now what is concentration? In this, if I talk about what is the concentration of milk, the concentration of milk is nothing but the volume by parts. Now what is the volume by parts here? We have 3 parts of milk and 2 parts of water. Or this can be understood as the volume of milk is 3x and the volume of water is 5x. What is the total volume here? 5x. The volume of water here is 2x. Now, what is the total volume here? The total volume, since I have only 2 ingredients in this mixture, so I'll say that the total volume here is 5x or 5 parts, which is equal to 100 liters. Thereafter, I'll be able to say that one part or the value of 1x here is how much? 20 liters. What is this known as? This is known as the proportional constant. So when we are talking about volume concentration, we will talk about the proportional constant also. So for further discussions, whenever I am using the word V, that means I am talking about volume. C means, capital C means concentration, and PC means the proportional constant for that reaction or for that mixture. Okay, so coming back, what is the concentration of milk in the original mixture? We will say volume by parts of milk, which is 3, divided by the total volume by parts, which is 5, which is why we will say the concentration of milk in the original mixture is 60%. Thereafter, we would say that the concentration of water is how much? The concentration of water here is 40%. I hope this part is clear. I hope. Now, once we know this, now then we can go ahead. Now, how do we need to go ahead? Okay, in the first case, we are only talking about removal. So I'm assuming here if 20 liters of the mixture is removed, then what is going to happen? So if 20 liters of mixture is going to be removed, the initial volume denoted by V is 100 liters. Can I say now V1? Now V1 refers to the first operation that has been done. And here there will be only one operation that will be done. So for further discussions, if I am writing M1, W1, V1, V2 and so on, 1 and 2 would refer to the operations, the number of operations that would have been performed in that case. Here there is only one operation being performed, here only one, here 2 operations, and here we'll be again performing 2 operations. In this video, we'll be talking about only first 2 cases. And then in the second video, the second part of this, we'll be talking about the remaining 2 cases, and the remaining 2 cases here are C and D. I hope I have made myself clear. Okay, so when I say 20 liters of the mixture is being removed, then can I say that the moment I say 20 liters of the mixture is being removed, it is just like saying 1x volume is being removed? So is it equal to saying that 1x or 1 part of the mixture is removed? Yes. And when 1x or 1 part of the mixture is removed, what is the volume thereafter? The volume thereafter would be 80 liters. This is the very first point that needs to be understood. After this, now we need to understand that if 1x part of the mixture is being removed, how will it get removed? I mean, I know that it is just like saying that I have taken a bottle of Pepsi, in which let's assume that there is water and cola as an ingredient, and when I drink it, so naturally the volume will get reduced, and I would have taken, let us say, 100 ml bottle, and I drink 20 ml from it. How much of that would be left now? 80 ml. Now that 20 ml which has been removed, that will be removed in the same ratio in which the cola and the water would have been present originally. If yes, then I need to apply the same logic here. Here 20 liters of mixture which has been removed will be removed in the same part, which is 3:2. So now we are tracing what? We are doing this question with the help of ratio and proportion, in which the removal of that 1x part or 1 part will be in the ratio 3:2 only. And why 3:2? Because originally the milk and water ratio was in the ratio 3:2 only. So the point that you need to understand at this stage is that the removal also will happen in the same ratio in which the ingredients were originally present. Right? I hope the point I have made it loud and clear. Okay. So now when I say 3:2, I have to divide 1x in the ratio 3:2, which is just like I have to remove 0.6x of milk and 0.4x of water. Another here is 0.6 parts of milk or 0.4 part of water I need to remove. So when I remove this is after the first operation. What is the ratio of milk and water? We get it as 2.4:1.6x, which is 3:2. So what is the learning from here? The learning from here is the volume of this mixture changes, but the concentration of the liquids originally present, the concentration does not change. And the example of Pepsi which I had taken, you can take the same example. It is just like saying that in the first sip, let us say I drink, let's say in the first sip I consume 20 ml. Thereafter, keeping every other ingredient constant, I mean everything constant, the ambience and everything constant, can I say that in the second sip the taste would be the same? Yes. Now what is taste here? Taste is nothing but the concentration of the liquid or the mixture or the ingredients originally present. Right? Okay. Another perspective to this is, now this is one of the ways. Now if I were to use percentages here, so this was with the help of ratios that you understood this. Now I am explaining it to you with the help of proportions. So ratios and proportions are nothing but two sides of the same coin, not of a different coin. Okay, so when I say 20 liters of the mixture is removed, 20 liters is what percentage of 100 liters? 20%. So can I say if 20 liters of the mixture has been removed, 20% of the mixture has been removed? Right? So how much mixture would remain? So can I say 80% of the solution is left now, which is nothing but the mixture remains? Now 80% of milk is to 80% of water is just like saying milk is to water remains the same. So even after the first operation, M1 is to W1, the ratio remains the same as it was originally. So what is the final understanding from here? Removal from the mixtures does not change the concentration of the liquids originally present in the mixture, because as of now milk is still 60% and water is still 40%. But what does it change? It changes, and which is a very obvious change. It changes the volume of the total solution. And when the volume of the total solution gets changed, individually also the volume changes. Right? Okay. Second part. Now wherein we are talking about addition only. So I have taken here, if 20 liters of either milk or water is added to the original solution. There can be other cases also which can be formed. Now what are the other cases? When I am adding, I can add milk only. I mean, use the same logic. When I am adding, I can add milk only, or I can add water only, or I can add a combination of milk and water to it. So there are three cases which can be made here. But I am just taking two cases as of now, because this is the first session wherein we just need to understand the basics behind, and then we can always take it to a next level. Okay, so now when we say this, we have already calculated that the value of 1x, if I am adding 20 liters of milk, is the first case that I am considering. So after the first operation, M1 is to W1, wherein I am adding milk to it. Can I say originally milk was 3x? Now if I am adding 1x of milk, now the water volume by parts remains the same. It is only the volume by parts or volume of milk that changes, because I am adding milk in the first case. So now this becomes 4x is to 2x, and the final ratio comes out to be 2 is to 1. Right? In the second case, I know that I am adding only water, so that means the milk by volume would remain the same. The milk by volume by parts would remain the same. So milk remains as it is as 3x, and then I am adding another 20 liters of water, which is just like saying adding 1x to water. So this becomes 3x is to 3x, which is 1 is to 1. So can I say now originally, here how much was V? V was 100 liters. And how much is V after the first operation, which is V1? 120 liters. So can I say addition changes the volume? Yes, it does. And does it change the concentration of the liquids originally present? Yes. So by adding, what am I saying? Both V and C change. By adding. And why do we say this? Because originally milk was 60% and water was 40%. How much of milk do I have now? So if I check how much of milk after in the first case when I am adding milk only, it comes out to be 2 by 3, which is 66 2 by 3%. And the remaining thereafter is water. Naturally, it is obvious, if you are adding milk, the concentration of milk would increase. It has increased. Now, in the second case, you are adding water only. Naturally, it is understood, and it is quite obvious also that the concentration of water should increase. So now milk and water, both of them, the concentration of milk and water, both of them is equal to a 50%. And naturally the concentration of water has increased from a 40% to a 50%. So if you feel that something, you learned something great today and this enhances your knowledge base, please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all so that you start receiving updates from us. If you want us to do some specific videos on specific topics, please put it in the comment section. Thank you so much. Until next time we meet, goodbye.